Okay, we're going to talk about transformations. You've seen the toolkit functions. We're going to look at what happens if we just tweak them a little bit, and actually knowing those basic graphs, you can graph a whole bunch of other things that are just shifts on those graphs. So we're going to look at functions that have the form y equals a f of b parentheses x minus c plus d. Look at what each of those letters do. So to start with, the A is a vertical stretch or squish, depending on whether it's greater than 1. So it's a vertical stretch if the absolute value of A is greater than 1. It's a vertical squish if the absolute value of A is less than 1. And if A is negative, it just flips your graph upside down. So if A is negative, you flip the graph upside down. So let's just look at an example. If I have f of x is equal to the absolute value of x, we know that's a v, right? So that's y equals the absolute value of x. So suppose I put a constant out in front now. Y equals 3 times the absolute value of x. Well, 3 is greater than 1, so that's a vertical stretch. So instead of, for example, 0 is your anchor point, so that's going to stay the same. But now instead of having the point 1, 1 here, it's getting stretched up. So I'm multiplying this y value by 3. And so my new y value is 3. My new point is 1, 3. The same thing over here. Instead of having negative 1, 1, I'm multiplying that y value by 3. 3 times 1 is 3. And I have a steeper v. So you can imagine that whole graph just got pulled up like this. So that's A. What about B? Well, B, let's change colors back again. B is a horizontal stretch or squish, okay? And it's backwards, okay? So it's a horizontal stretch if B is less than 1. Horizontal stretch if B is less than 1. And it's a horizontal squish if B is greater than 1. Okay, the ones on the inside kind of work opposite what we would think. So for example, let's look at f of x from negative 3 to 3. This is the easiest way to demonstrate this one, is just graphically. So here's a semicircle, okay? And this is f of x. Suppose now I want to look at f of 2x. Well, what is that doing? It's taking my whole graph and squishing it horizontally. How does that translate? Well, anything on the y-axis here, where x is 0, is an anchor point. So this point isn't changing. But what's happening now is that these values are getting squished in. And how do I get them? I do the opposite. So this is multiplication. I divide 3 by 2. So now it's 3 halves. If I divide negative 3 by 2, I get negative 3 halves. So now I have a squished semicircle. I've turned it into an ellipse. And it just moves everything in, okay? Similarly, if I want to know what about f of 1/2 x, well, that's going to stretch this by a factor of 2. So again, I divide by a half or multiply by a reciprocal. So anything on the y-axis again is my anchor point. But now instead of being negative 3, I'm going to be out here at negative 6. I'm multiplying it by 2. Instead of having an x value of 3 over here, I'm going to have an x value of 6. So now I have this stretched out shape, which is an ellipse in the other direction. And it's just taken the whole thing and stretched it. So all you have to do, you're looking at x values, okay? For B and C, we're looking at the x values. For A and D, we're looking at the y values. So we've seen that A is a vertical stretch or a vertical squish. Again, I could come back over here, and if I want to know y equals 1/2 the absolute value of x, I would squish it down. So instead of 1, 1, I would have 1/2. Instead of negative 1, 1, I would have negative 1/2, and I would get a much wider V. Okay, it's been squished down and made fat. With the B, again, if B is greater than 1, I have f of 2x. It's compressing the whole thing in. I'm dividing my x values by 2. If I have f of 1/2 x, it's stretching the whole thing horizontally. So I am multiplying everything, all of my x values by a factor of 2. All right, let's look at C and D. C and D are our shifts. So if we look at that, okay, what does C do? C is a horizontal shift. C is a horizontal shift. So f of x minus c shifts the graph c units right. It's an x value thing. It's shifting it left and right. If I have f of x plus c, so c is negative, it's shifting the whole graph left. Shift c units left. Some of you guys will have seen this before. So for example, I know that y equals x cubed looks like this. Y equals x cubed. So if instead I have y is equal to x minus 3 cubed, what does that do? It just moves my whole graph 3 units to the right. So I take this reference point and I move it 3 units to the right. Okay? And then what's happening? I'm getting the same shape shifted to the right. Okay? Similarly, if I have y equals x plus 2 cubed, well, what's that doing? It's shifting the whole graph 2 units to the left. So again, the same shape shifted 2 units to the left. Doing my best to try to make them look parallel, but I'm not perfect. All right, so C is a horizontal shift. And lastly, we come to D. D is a vertical shift. So D is a vertical shift. So it's a vertical shift D units. So when I have plus D, shift D units up. And when I have minus D, shift D units down. So let's just take another graph that we studied. We had one of our other toolkit functions was the exponential graph. Y equals e to the x. Looked like this. Crosses the y-axis at 1. So if I add something on to the end here, y equals e to the x plus 3. What's happening is just raising the whole graph up 3. So 1, 2, 3. That puts me at 4. Same shape. Shift it up. Notice since e to the x is never equal to 0,